Hello everyone and welcome back to Introduction to Number Theory. In this video we will discuss arithmetic properties of congruence modular n. So let's take an arbitrary integer n, or you may assume that it is a positive integer. It doesn't change anything. And let's take arbitrary integers a1 congruent to a2 modular n and say b1 congruent to b2 modular n. And it is quite natural to expect that a1 plus b1 be congruent to a2 plus b2 modular n. So we just add the left-hand sides to each other and add some right-hand sides to each other, and once again gain congruent integers. Also, it is natural to expect that a1 multiplied by b1, so now we consider the multiplication, be congruent to a2 multiplied by b2. And also we may expect that a1 minus b1 be congruent to a2 minus b2, of course modular n. And the fourth arithmetic operation, which is the trickiest one, is the division. We may expect that a1 divided by b1 be congruent modular n to a2 divided by b2. So, in fact, three of these properties hold for any four integers a1, a2, b1, b2, satisfying this condition. But one of them, well, I advise you never to use it, or use it very carefully. As you may already have concluded, those three that always hold are about the sum, about the multiplication, and about subtraction. So these three hold in any case. But the last one, concerning the division, well, it's sometimes true, sometimes not. And there are cases when we can say in front whether it will be true or wrong, and we will discuss these cases today. But please be very careful when using division together with congruence modular n. Let's start from proving that these three hold. Well, proofs are very similar, so let's consider just one of them, say multiplication. And now we will prove that a1 multiplied by b1 is congruent modular n to a2 multiplied b2. It's a very simple proof. Well, since a1 is congruent to a2 modular n, we can say that a1 is equal as an integer to a2 plus n multiplied by some integer alpha. And since b1 is congruent to b2 modular n, we can say that b1 is equal to b2 plus n beta. And then just multiply a1 and a2 and b1, a1 multiplied by b1, just as here, is equal to a2 multiplied by b2 plus, well, we should multiply these summands and also multiply these summands and also multiply these summands. And all of them can be written as n multiplied by a bracket, in which we have a2 multiplied by beta plus alpha multiplied by b2 and plus n multiplied by alpha and beta. So the brackets close here, and we see that this part here is of course divisible by n. So therefore a1 b1 is indeed congruent to a2 b2 modular n. Okay, so in order to prove properties concerning addition and subtraction, just use the same representation of a1 and b1 and conduct these operations. Now let's discuss the division. What about this property here? Is a1 divided by b1 congruent to a2 divided by b2 modular n? As I've already said, there will be cases when this holds. There will be cases when this doesn't hold. For instance, a1 might not be divisible by b1, so this not being an integer, we don't quite know what is congruence of non-integers. But even if a1 is divisible by b1 and a2 is divisible by b2, even in this case, you may have, there are counterexamples of that show that this property doesn't hold in any case. I suggest you find these counterexamples on your own. Now I would like to focus on a specific condition in which this actually holds. Pay attention to b1 and b2. If b1 and b2 are both mutually prime with n, well, in this case, the division property holds. It doesn't matter, well, of course, a1 and a2 should be divisible by b1 and b2 respectively. Of course, these two expressions should be integer. But a1 and a2 needn't be mutually prime with n. It actually doesn't matter what are the common divisors of a1 and n, a2 and n. But if b1 and b2 are co-prime with n, then this holds. Let me try to explain why is this so. Well, once again, if b1 and b2 are co-prime with n, then in this case there exists a fifth integer c such that b1 multiplied by c is congruent to 1 modular n. And of course, since b1 and b2 are congruent to each other, then b2 multiplied by c will also be congruent to 1 modular n. So instead of dividing a1 and a2 by b1 and b2, we can consider multiplying them by c. I mean that a1 divided by b1, well, we can represent this as a1 multiplied by 1 over b1. Of course, this is already not an integer, but just to explain how this works, 1 over b1 modular n is congruent to c. And a2 divided by b2 being equal to a2 multiplied by 1 over b2. Of course, this is not an integer, but nevertheless, if we transfer ourselves to arithmetic modular n, then this is a correct sentence. And it will be congruent modular n to a2 multiplied by c. So we know that a1 and a2 are congruent to each other. Thus, multiplying them both by c, we will gain, once again, congruent integers. So please remember that in case b1 and b2 are mutually prime with n, then you can divide modular n.